So the title of the talk is Global Warming. Is it real? And if so, are we to blame? The reason I chose that is many people agree there is warming, but there are also a few who don't. So you need to discuss their views as well. I changed, okay. So what is the evidence that the Earth is warming? And what are the consequences? This is the structure of my talk. Then, is this due to us? And if so, what can we do? I cannot touch, I'll only touch on the what we can do because there's not time for it. It'll require a separate talk. Other people, there are others, maybe 5% of the people think there are cosmic factors over which we have no control. So I'll present that also, and then we can have some conclusions at the end. Is the Earth warming? So what is the evidence? The evidence is 3 or 4-fold. It's in increasing droughts and floods, the permafrost melting, and alpine and continental glaciers melting. I shall take you on a world tour. Remember, this is a global thing. It is not what is affecting Kerala or your town or your village or India. It is actually a global thing. I want you to understand that what happens in the Arctic, which you cannot relate to in Kerala, is caused by you. And likewise, what happens in the Arctic affects you. So the most obvious effects of global warming is increasing droughts and wildfires. So if you have increasing droughts, you'll have reduced food production. We have that seen that in years in Maharashtra in India, failing crops. The other thing is you see increasing frequency of fires in Australia, California, Italy, and prove it is due to climate change. But when you suspect, it is related to climate. Climate science, I'm not a climate scientist. Climate science is not an exact science, like a laboratory science. Everything is not laboratory, it's not testable. So always leaves room to oppose. Increasing floods. In 2018, the biggest flood in the world, you had
Hello. Sorry, your voice is breaking. Sir. Hello. Sir. Hello, Zahir sir.
just spoke to him, and the internet cut out, and he's just connecting again. So apologies to everyone for the interruption. We should resume as soon as possible.
Thank you, Sultana.
Sir, your audio is not.
Zahir, you are muted.
Even in England, which used to have very fine rain, very misty, drizzle-like rain, from time to time, we are seeing torrential rain, like monsoon rain in Kerala. Tewkesbury in England, 2020, there was a flood. And this did not happen in the last 20, 30 years, but we are seeing this every year. So obviously, it is not, in some places, it's occurring everywhere. The melting of the permafrost is another sign of global warming. So now, what is the permafrost? It is made of soil, rocks, and sand held together. And this exists even over 2 years, even through summers. And some parts of the world, you have this in northern Russia, Siberia, Alaska, those kind of regions. Now, what is happening is the permafrost is thawing in Alaska, Siberia, Canada, Greenland, etc. Now, you may ask, so what? The problem is it contains semi-rotted vegetation, and that releases gas causing global warming. Then you have the disappearing glaciers, and that is further proof of global warming. And two types of glaciers, alpine glaciers and continental glaciers. The alpine glaciers, I will call them mountain glaciers. In geology, it's called alpine glaciers. Continental glaciers cover entire land masses, so they're not on mountains, and they move from the center to the sea. So just have a look at some alpine or mountain glaciers. It is actually a slowly moving solid river of ice. It's flowing downhill at very slow speed due to gravity. So like a water river flows down quickly, here this flows down very slowly. So here at the bottom, you have the Gangotri Glacier in India, which is the source of the Ganges. Other well, there's glaciers that join together. In the right, upper right, you have the glacier and the Karakoram range. Backwards. So this is a picture of a the point where glaciers geological process. Differences so will disappear. What are in the next section? Oh. Glacier is a source of the Ganges, and you can see it is receding also. So this is a position 1780, the top arrow. Now melting Hello?
Hello. Now it's suitable, sir. So in between we are breaking, sir.
Glacier, it arises in Sweden. It flows, the river flows into Geneva, Lake Geneva, and out into France to the Mediterranean Sea. Okay? So this is the RHONE glacier in 1900. You see that point with the arrow, red. Now you look at it in 2008. The snow has disappeared, the glacier has disappeared. It's all bare rock there. So the glacier has receded 1.3 kilometers in the last 120 years, leaving behind a track of rock. So these magnificent cities of Europe will have a shrinking lake and river. You have the river Rhone coming from top and it's entering Lake Geneva. And you can see Lake Geneva with a fountain. And you have the castle of Chillon on Lake Geneva. So the river and the lake will shrink. Global warming reduces capacity for hydroelectric power, where the source is a river from a glacier. So hydroelectricity in some places relies on glacial water. So you have water at a high level, it has high potential energy, is flowed downhill, and it turns a turbine and generates electricity, which is sent to a transformer into power transmission cables. So the Idukki Dam in Kerala is not a glacial river. Periyar is not a glacial river. But the Bakranangal Dam and others in northern India depend on the glacial water. So when the glacier recedes, initially you will get, due to the melting of the ice, high flow. But eventually, as it recedes too much, you'll not get enough flow. Receding alpine glaciers even has impact on nuclear power generation. Nuclear power, you'll wonder why. See, water is needed in the heat exchange condenser circuit. So in the but water is used as to generate the steam which goes into the turbine and produce the electricity. And the steam that and invented out this if the cooling water gets to, the power has to be reduced. down the river France, and there are a lot of nuclear reactors along this river, and it's cooled by the river water. In 2018, nuclear plants in Nordic countries, that's Finland, Norway, and Sweden, had to be shut down due to seawater reaching 25 degrees. So nuclear power plants don't generate CO2, but even they cannot run without cold water. Now, the effect of continental glaciers is something else. The mountain glaciers do not raise the sea levels as much, but the problem with the melting of the continental glaciers is that they raise sea levels. So you look at the North Pole and the South Pole, you have Antarctic and Arctic, and you have two glaciers there, solid sheets of ice. Snow. Article time faster, and the ice is disappearing. And the article in the Deccan Herald actually says that it has reached tipping point. So even if global warming stopped today, Indian Ocean and 1,255 square miles of ice broke up and ended in the Weddell Sea. The Weddell Sea is here. The melting of continental glaciers will have a big effect on coastal flooding. If you look at the data, the sea height from 1992 to 2020, so a period of 27 or 28 years, it has been rising at 3.3 millimeters per year. So in this period, 1993 to 2020, the sea has risen 9 centimeters. And it has risen since 1900, 20 centimeters. So in the last 27 years, it has been half the rise. If all the Antarctic ice here melts, you'll have 57 meters of sea rise. Now, there are a lot of simulations showing what will happen for different levels of ice melting. If all the ice melted or part of it melted, you can model that. What will be the sea level rise and what will be a coastline? So have a look what will happen to the coastline of US. All these cities, New York, Boston, Washington, DC, all the coastal cities, part of Florida will disappear under the sea. So coastal populations will be displaced. Likewise, you look at the map of Europe after sea rise. The white arrow, that is the eastern part of England. You have London and East Anglia. All that will disappear. Whole of northern Germany will disappear, and Benelux countries will disappear. And down in Italy, you'll have Venice and other places disappear. Even the volcanoes, Vesuvius and Etna, will be under the sea. Now let's look at Asia, where huge population lives. Starting with Japan and China, whole of Shanghai and a large region of eastern China will go under the sea. In India, Gujarat will become an island, and you will get the western part eaten away. Bangladesh has a huge low-lying area, so that'll go under the sea. And Kerala, a lot of its territory will go, probably up to the Western Ghats. So this will be the effect of the continental glaciers melting. An unexpected effect of melting of the glaciers and permafrost is more bacteria and viruses will be revealed. Researchers have found bacteria and microbes which are 500,000 years old and revived them. And as glaciers melt and masses of microbes, some 750,000 years old, are released from the ice. On the right, from a Russian newspaper, there were worms frozen in the Siberian permafrost, and they could bring them back to life after 42,000 years. The mechanism of the warming is believed to be the greenhouse effect. So let me illustrate it with glass first before going to gases. So in a glass greenhouse, you can grow crops even in winter. It'll be cold outside, but it'll be warm inside. And what happens is light from the sun passes through the glass roof to heat the plants. The objects inside the greenhouse, they emit infrared radiation, which is not able to go through the glass roof. So the interior gets hot. So even if you have not experienced a greenhouse, you'll have observed this wherever you are. If you leave a car in the summer with the windows closed, the inside gets hotter than the outside. For example, after 10 minutes, if the outside temperature was 27 degrees, inside would be 37 degrees centigrade. You'll notice the temperature will not rise unless the glass windows are closed, and this will not happen.
Sir, you miss you in between. Hello.
Yeah.
Yeah, you miss you in between. Between. Body was breaking in between.
Zahir, may I suggest one thing? You can use your mobile to speak on, perhaps. Is it possible? Zahir? Zahir, is it possible for you to use your mobile to speak on?
And you can see a lot of Asia will be affected. Microbes will be released. Okay, now I'm coming to the mechanism of the greenhouse. So this will not happen at night, and you can see the inside of the car is getting hotter than the outside. There's no fan or heater inside. So does it violate the first law of dynamics? So the greenhouse effect with glasses raises temperature. That was John Tyndall in 1815. In 1956, an amateur scientist unit of solid to bigger things as well. Outside, and you shine two lamps of the same wattage. So in a way, Okay. Can you hear me?
Yeah, but the presentation is not visible, sir.
Presentation not visible?
Yeah.
I will do the presentation, just 1 minute. I will do the presentation. I've asked Dr. Bashir just to speak. That way his internet will hopefully hold up.
Okay, thank you, madam.
Can you see?
Yeah. Now it's visible, yeah.
Okay, let me just hit the sidebar. Okay, let's hope this works. Okay, go ahead.
Okay, which slide am I seeing?
Why don't you, we couldn't hear you, so why don't you just go through the greenhouse gas thing again?
Okay.
Sorry, is this the green? Yeah, start, yeah, go ahead with here, yeah. Yeah?
Okay, the CO2 raises the temperature, and John Tyndall was the first person to recognize it. Hello?
Yeah,
It's audible, sir.
Okay. And there was a American scientist called Eunice Foote who discovered it 3 years earlier, but she was an amateur scientist and a woman, and so she doesn't get as much credit as John Tyndall. Can you go to the next slide? Yeah, this is a school experiment where 2 bottles, one containing carbon dioxide, one containing air, are heated by 2 lamps of the same wattage. And then you measure the temperature inside and you plot it, and you'll see the carbon dioxide, the bottle containing carbon dioxide is 5 degrees higher with the air compared with the air. So that clearly proves that carbon dioxide absorbs infrared and gets hotter. Next slide. Hello?
yeah, is that right?
Yeah. So you have to see the Earth. It is like you have a glass dome over it, just like the glass window of the car. So the infrared that is coming in from the sun, it gets transformed by the Earth to a lower wavelength infrared, which is not able to go through the carbon dioxide layer. It's reflected back to Earth, just like the glass window does, and so the Earth gets hotter. Next slide. Okay, now the greenhouse effect, we're not saying it's all bad. Without it, in fact, life is not supportable. If there was no greenhouse gas or no atmosphere like the moon, the Earth's temperature would be minus 18 degrees. So life would not be supportable. You need the greenhouse to keep you warm, but you don't want the temperature inside the greenhouse to rise too high. Otherwise, you cannot live either. Can you go to the next slide? So this shows the CO2 has doubled from 200 ppm, parts per million, to 400 parts per million in 150 years. On the left, you have a period of 420,000 years, and the average, running average is about 250 ppm. But in the last 150 years, the CO2 level has shot up. And that's where the problem is. Next one. You can skip this. Okay. What are the greenhouse gases? Next one. The Kyoto Protocol names 6 greenhouse gases, of which carbon dioxide, methane, hydrofluorocarbons, and several are there. The sulfur hexafluoride, which is used in power stations because it has high electrical breakdown. But carbon dioxide is the main one. Its curve is rising, and we need to have flattening of the curve like you have for the COVID. Nobody is attending to that, so it keeps rising. Next one. Carbon dioxide is held as the main one, even though methane is a stronger absorber, and so is nitrous oxide, and so is water. The reason is carbon dioxide is not a condensable gas, and it has a long lifetime in the atmosphere. It can stay up to 10,000 years. So if you keep adding more, it'll keep building up more. On the other hand, water absorbs infrared more strongly than carbon dioxide, but it has a 10-day life cycle. It'll condense and fall back to rain. So you can remove it. Carbon dioxide, on the other hand, keeps building. If you keep adding, it'll just keep building and the temperature will keep going up. Can you go next slide? You can skip that because I explained that. Next one. Next one. The water amplifies the heating effect of the carbon dioxide, but is not considered the prime driver because the water can be condensed and taken out. However, if carbon dioxide adds 1 degree, the water will add 2 degrees to it. Next one. So basically, man-made CO2 has disturbed the delicate equilibrium that supports life. Next one. Burning a fossil fuel generates carbon dioxide and water. So the principal fossil fuels are coal, that is carbon itself. So when you burn it with oxygen, you'll get carbon dioxide and heat. Then you have hydrocarbons. You have the gaseous hydrocarbons. Methane is the main one. If you react that with oxygen, you'll get carbon dioxide and water and heat. You also have liquid hydrocarbons like petrol. And that also, when you react with oxygen, you'll get carbon dioxide and water and heat. And that is used to run your car and other things. Next one. Now, carbon is the central element of life, and it's also the source of energy. So all things contain, living things contain carbon and compounds of carbon with hydrogen, oxygen, nitrogen, sulfur. And the reason is carbon can make 2, 3, and 4 bonds. It can make ring compounds and chain compounds like polymers. Silicon is in the below carbon. It can also make somewhat similar compounds, but you cannot have the basis for life. Silicon is the basis for electronics, but not for life. Next one. Now, how is carbon and natural gas, methane, and petrol formed? It is formed when, in the case of coal, when dead vegetation dies and sinks, is compressed by heat and pressure over a long period, all the oxygen and other elements are squeezed out, you're left with coal. In the case of formation of oil and gas, you have, from the sea, you have living creatures that die, and the sediment sink to the ocean floor, and they get sedimented further and further. And these decompose to methane, gas, and to oil. Next one. Now, carbon dioxide is actually an essential part of the life cycle. We have photosynthesis of plants. Carbon dioxide plus water plus energy gives glucose, which is food, plus oxygen. Respiration or breathing is the opposite. Can you go back? Yeah.
Right.
There you, no, go back. Yeah, there you're taking glucose from plants, and you're getting carbon dioxide out. Next one. Okay, we just finished that. Okay, so the first fossil fuel that fired the Industrial Revolution was coal. So the 18th, 19th century was dominated by coal. Next one. The second fossil fuel, which has dominated the 20th century, is oil. Crude oil, on the, you can see it's a black, thick liquid. And when it's refined, you get the various oils, kerosene, petrol, etc. It's separated by distillation. Next one. And the crude oil is called black gold, and it's the backbone of all industrial economies today. You can see the size of the plants, and it's an impressive feat of science and engineering. Next one. And the oil tanker ships the black gold that fuels the global economy. Just look at the piping aboard the tanker. Next one. An even greater feat of engineering is extracting oil from under the sea. Can you go up?
I'll go back up, yeah.
Okay, so oil has been found under the sea as well, offshore. And the North Sea oil in Britain has been used for 30, 40 years, but it's coming to an end, it's depleted, and they'll have to remove all these rigs and tow them back to the mainland. Can you go to the next one? Okay, there's another fossil fuel that is claiming to be clean. That is liquefied natural gas, or LNG. And Qatar produces a lot of this. This is the cooking gas that you use at home, which is supplied in cylinders in India, but in Western countries, it's piped directly to the home. Now, methane, you might have seen those adverts from ExxonMobil on Indian TV claiming to be a cleaner fuel. That's only partially correct. It is cleaner with respect to coal in that it doesn't generate soot and it will not create smog. But still, when you burn it, it will convert to carbon dioxide. That's invisible, but causes global warming. Next one. Now, there is something they have found, which is called methane hydrates. It's the next fossil fuel or the next danger. So basically, it contains CH4 surrounded by water molecules, 23 water molecules. And this is bound in a cage, and this is found under the ocean and is kept that way due to the cold temperature and the pressure. You can take this out and light it with a fire, and the methane will burn. Yeah, can you go to the next one? Skip the next one. Skip. Yeah. The gas hydrate reserves is 3 times other fossil fuels, that is oil and natural gas and coal. And it has been located in all the continental margins, right? You can see on the western coast of America, South America, Africa, India, all the coastline areas. And it is found at shallow depths of 500 to 700 meters. So there's a lot of it, and the danger is now that people will run after this, and you'll convert all this to carbon dioxide instead of alternative fuel. Next one. Okay, so already Japan, India, China, Canada, United States, they're doing research on this, extracting the methane hydrates from under the sea floor. And Canada and Japan had a program where they have actually done commercial trial runs where they have produced this methane from the hydrate. Next one. The problem is the methane hydrates are too tempting for countries to miss out on. So they will dam Kyoto and go after it. And so what you'll do is you'll take the methane from under the sea and you will convert it to carbon dioxide. And that will make alternative energy uncompetitive. That is the great danger. Next one. Now, there are interacting factors that could cause a runaway reaction. By interacting factors, I mean warming causes a reaction that causes further warming. Next one. So an example of the interacting factor is the albedo effect. You have the 2 poles, Arctic and Antarctic, with ice. Supposing that starts melting, what will happen is the Earth, the whiteness will go and the Earth will become darker. And darker objects absorb radiation, heat, more than white objects. So the global warming from carbon dioxide will reduce the heat reflecting capability of the Earth, and it'll get hotter still. So the ice will melt even faster. So that's an interacting effect. Next. And likewise, if the permafrost melts in Alaska and Siberia and others, you'll get more CO2 and methane released, because under this is semi-rotted vegetation. And when they rot more, they release carbon dioxide and methane. Next one. Another effect of these methane hydrates. These are kept under cold water and pressure. But if the temperature rises, these methane hydrates will expand 164 times their volume. So now it depends whether it will gradually come out or it will come out suddenly, in which case they can detonate like a bomb, like you had in Lebanon. It'll detonate over the sea. So this is a great danger. Next one. So if you have uncontrolled decomposition of the methane hydrates, you can have detonation. And in the Arctic Sea, in the Barents Sea, researchers in Norway have found under the seabed of the Barents Sea, where you have these methane hydrates, massive 1 kilometer wide craters, which has been caused by methane hydrates exploding 12,000 years ago. It exploded under the sea, and if something that severe explodes, it's bound to have an effect uphill as well, above the sea. It may lead to tsunamis, or it may lead to gas coming out and igniting. Next one. In 2014, mysterious craters were formed in northern Siberia in the Yamal Peninsula, in the yellow area. These craters don't look like sinkholes. They actually look as if they have been, something has exploded, because they found rocks outside. And this is believed to be due to methane coming overground and exploding. And this is coming from the permafrost. So this is on land. Next one. Now the climate change deniers, a few deny that is temperature rise, or they deny carbon dioxide is the cause. Now, even though the bulk of the scientists accept temperature rise is due to carbon dioxide, there are still people who oppose it. Next. They have four arguments. One is that carbon dioxide is a very small amount. It is 0.04%. So how can such a small amount make global warming? That's one argument they use. Second is they say greenhouse effect violates the first law of thermodynamics. How can it get hot inside, like in the car? Some of them claim violation of the second law of thermodynamics. They say heat flows from the hot to the cold. So how can the cold atmosphere radiate and warm the earth? So a fourth type says that actually it is not due to carbon dioxide. It is due to change in tilt of the Earth's axis, or it's due to sunspots changing, and that is causing the global warming. So there's little we can do. We are not responsible. Next one. Now, small things causing a big effect, you can ignore the text. Just look at the picture. You have potassium permanganate dissolved in water. If you put one crystal, you can see it absorbs strongly, it starts going pink. If you just put 5 crystals, it'll go dark. So carbon dioxide is like that. It doesn't absorb in the visible, but it absorbs in the infrared, and it absorbs very strongly. So that means a small amount can have a very big effect. So that's no mystery. Next one. So the cold atmosphere cools the earth. This is what the Australian far-right senator, One Nation Party, says. He says it's impossible that, that the atmosphere, which is cold, is heating the earth. However, it doesn't work like that. This is based on infrared radiation. And in radiation, cold objects and hot objects emit. The net flow from the sun to the earth is in the direction of hot to cold. But locally, there can be these effects due to radiation. Next one. So others claim that it violates the second law. And later on, I can explain that that's not correct. There's no violation of the second law. And I mean, what's happening is if you do an energy balance, you'll find what is coming doesn't exceed what is going out. Next one. You can skip this as well. Now, global warming is occurring due to changes in the Earth's rotation. You have these kind of websites proposing this. They are in fact taking NASA data, which shows global warming changing due to Earth's rotation, but that occurs over a period of 12,000 years. It doesn't occur in 100 years. So they take scientific reasoning from somewhere and twist it to explain that's not happening. There are a lot of people who want to say that we are not responsible, and they're looking for reasons for that. It's like fake news. Next one. So the sun is responsible for the warming. So what they are saying is, you know, the sun surface sometimes show these spots. They're called sunspots. They occur at 11-year intervals. It's periodic. Okay, so it oscillates periodically, the number of sunspots. If the temperature was correlated with the sunspots, then the temperature of the Earth should be going up and down in the same way. However, on the right, you see the temperature of the Earth is just going up continuously. And that correlates with the carbon dioxide going up. Next one. Even university people sometimes publish papers, like University of Braunschweig in Germany. It's a respectable university. And two scientists there published a paper saying that falsifying the greenhouse theory. And this, however, has been dismissed by NASA and other scientists. The problem is people then cite this, politicians then cite this to say that the matter is not clear. Next one. So generally, the climate change deniers, they work like fake news peddlers. These are written on internet blogs without peer review. Some are keen to show the scientists are wrong. Some quote but misunderstand the science. And usually they believe there is a conspiracy to curtail freedom and lifestyle. And then there are many politicians who quote this pseudoscience. Next one. So mitigation schemes, I'm coming to the end. I cannot go into detail on this. Next one. Okay, so we have to look for fuels and alternative energy sources to prevent the CO2 buildup. So that means solar photovoltaic, electric cars, more wind, more hydro, even nuclear power, but it has other dangers. For the carbon dioxide, the other thing we have to do simultaneously is carbon dioxide capture. One is the natural and bio-friendly approaches like planting trees and forests, because those take carbon dioxide by photosynthesis. There are also technologies, engineered technologies for carbon dioxide capture, which is under research and development. And I would like to say that even oil companies like ExxonMobil are making an effort in that direction. They are looking for more fossil fuel, but they're also making an effort in that direction. And there also has to be a carbon tax to reduce the use of fossil fuels. Next one. So carbon pricing is one of the most effective ways. So one must pay a true cost to cover the invisible pollution created by adding CO2. And only this way, clean energy or alternative energy, which doesn't involve CO2, becomes competitive. And of course, the critical factor is the economy of growth. If you keep having more and more and spending more and more and consuming more and more, you'll have pollution. Next one. So we come to the conclusions. Most of the scientists agree that, next one. Most of the scientists agree that the Earth is warming, and the reason is carbon dioxide created in the last 150 years due to human actions. There are some deniers and some politicians and people do not want to curb their lifestyle, but burning fossil fuels generates CO2, and coal was the first one, and now we have methane and oil. Next one. Interactions can make a runaway scenario. So you can have the thing multiplying fast and going out of control. The methane and CO2 released increases the permafrost. It will increase as the permafrost thaws, and that will accelerate the global warming. Methane hydrates under the sea can release methane as the oceans warm. The question is, should you extract it as a fossil fuel, or there may be uncontrolled release, which can cause explosive detonation above the sea. And as the ice caps melt, the albedo changes, so the Earth's absorbance increases, and that heats up further. And even non-fossil hydroelectric and nuclear power plant get affected because you don't have either water for cooling or for running the turbines. Next one. The consequences of disturbing a delicate equilibrium is the extinction of life. You'll have less land to live on. You'll have droughts and floods, forest fires, glaciers recede, rivers dry up, runaway interactions. But the Earth will adjust to a new equilibrium, but it may be without man, without humans. Whatever happens, the Earth adjusts to it. So human beings can become the victim of their own success. Next one. Now, solutions require collective effort because it is not a national problem, it's an international problem. And we need to do things together. And that is move from non-fossil fuel to fossil fuels to non-fossil fuels. We have to reduce consumption. We should have an equitable distribution of the burden between developed and undeveloped countries. There's also the population problem of population growth. Population is 6 billion now, and by 2050 it'll become 9 billion. So global warming requires international cooperation, and we cannot be restricted by nationalism and ethnic rivalries and all those things. It requires complete cooperation, and like COVID, we have to flatten the CO2 curve. Next one. That's my final message.